I told you so.
Welcome back to Advanced Algebra for 10th grade, and this time we'll discuss about logarithm with other bases. So before we go to with other bases, so let's discuss or review first about base 10 logarithm. So this is one of the example of base 10 logarithm. In the statement of exponential, we see that 10 to the x power equals 1000. Okay, now let's transform this into logarithm. As you can see, if we transform to the logarithm, we see from the perspective of exponent. So 10 to the x power, the x power is the exponent, so x equals log of 1000. Okay, so that this is the transformations that we've learned before, and I just want to emphasize that we are seeing the logarithm based in the perspective of the exponent. Therefore, a logarithm is an exponent, right? Because the logarithm of 1000 equals x, and x is the exponent. Okay, let me repeat again. Logarithm is an exponent. Now let's go to base other than 10. Okay, so what happens if we are dealing with a base that is not 10? So for example, if I have a statement in exponential equation, 4 cubed equals 64, which is true, right? 4 cubed equals 64. And if I transform this into a logarithm statement or equation, I see it from the perspective of 3, since 3 is the exponent. So 3 equals log here, and then the 4 as its base comes to this position, okay, in the lower case, and 64, which is the answer of what 4 cube is, comes here. So I want you to remember the position, okay? And this, if you want to read it, okay, 3 is log to the base 4 of 64, log to the base 4 of 64. 3 is log to the base 4 of 64. So keep in mind that the 4, the base, comes from here to here, and the exponent will be the logarithm itself, and 64 as the answer will be the argument. I will explain you about the terminology later. So if we reverse the position, I want you to practice how to transform them from the exponential state equation into a logarithm statement, and vice versa. If you are given the logarithm statement, I want you to practice how to transform this into exponential equation. So how do we deal with this? We know that the base is 6 and the exponent is n, and the answer or the value of that power will be 36. Therefore, if we transform this into exponential equation, it will be 6 to the nth power equals 36. Okay, which so again, let me repeat: log to the base 6 of 36 equals n. You can transform into 6 to the nth power equals 36. And of course, by this equation, we can know that the value of n equals 2. Therefore, this is 2. So log to the base 6 of 36 equals 2. Now let's go to the general form. Okay, if we are speaking about base b logarithm, okay, this is another example. Just use b as the base. If we have this statement, y equals log to the base b of x, okay, it will be if and only if b to the y power equals x. Okay, yeah, this is just the general form after we have already discussed about the transformation. So let me remind you again that the b here is the base, and the y here x is the exponent, and the x here will be the value of this power, b to the y power. But there is a condition, okay, that we have to stick with it. Okay, first the x has to be positive numbers, and the b also has to be positive numbers, and the b cannot be equal to 1. Okay, since 1 as its base, if you have the power of anything, or y equals anything, any real numbers, so the value of the x will always comes to 1, right? So we only deal with the base that is positive, that is not 1, and the x here is positive also. Okay, that's the condition that we are dealing in logarithm. So I want to give you the terminology of each location. If we are speaking about logarithm, first, y itself is the logarithm. Why? Because y equals logarithm. So y is the logarithm, and before we have already mentioned also that y is the exponent. So the exponent is the logarithm, right? The exponent from this form will becomes the logarithm in this form, and the b itself will be, of course, the base. It is consistent either in this form or this form. B is always the base, right? But the x thing, okay, this one x is the value of b to the y power, but this is the location of the argument. Okay, we call it argument. So this is the argument of log. So I want you to keep in mind that the location of y log and the argument, sorry, the logarithm, the log here and the argument is on the same level. Okay, it's on the same level, and the base will be a little bit lower, so lowercase. And whenever you write the logarithm, I want you to be careful. Make a distinctive, make the distinction quite visible. Which one is the base and which one is the argument? Okay, you have to put it quite lower than the argument for the base. Okay, that is the thing that I want to remind you. So I want give you another example. If I want to use base s, I keep changing the letter, but it's just the same. Base s logarithm. So if I have this statement in logarithm, r equals log to the base s of t, okay, this is how you say it. Okay, I have already mentioned it. This is how you say it. R equals log to the base s of t, okay, and r is a logarithm, is a logarithm, and logarithm is an exponent. Therefore, r is an exponent. Don't forget that. Okay, and if I want to transform this into exponential equation, don't forget that s is the base, r is the exponent, and t previously in this form is the argument. But in the exponential equation, it will be the value of the power. So this is how you write it. S to the r power, sorry, equals t. Yeah, that's I know that I keep circling in this format because that this is the foundation, the fundamental thing that you need to grasp, to master before we deal with the properties. That, let's go back to base 10 logarithm. If I have the statement as the first page, that I say 3 equals log of 1000, we see that there is no base here, right? The base is not written. It's just the log and then the argument directly. And this is the exponent or the logarithm. Therefore, let me clarify. So originally, it's supposed to be like this, because we know that the base is 10. 3 is log to the base 10 of 1000. But as per the agreement, whenever we have 10 as its base, we don't have to put it. Okay, just like square root. If we put a square root, we don't use 2 as the root index. We don't write it. So for logarithm, if we have base 10 logarithm, it is not necessary to put 10 as its base. Just write it this way. It's enough. But if you want to do it completely, that's fine. But I want you to know that whenever you find this one, you have to know that the base itself will be 10, not 0, not 1, not other value. It must be 10. So now let's go to the example. Okay, now I will give you some example, okay, about the logarithm with other bases. So for example, we have to find the x. Now, there are three conditions, there are three different types of problems. Okay, we have to find the x. But for the first one, the x is as the argument here. The x is as the argument. For the second problem, the x is the logarithm itself. And the last one, the x is the base. So how do we find the value of x? Using the definitions of logarithm. So definition of logarithm, it means that we need to train or practice ourselves to convert this logarithm into exponential equation. So as you have learned before, so if I want to translate this into exponential equation, it means the base is 3, the exponent is -4 equals x. So 3 to the -4 power equals x. And in the end, of course, I can just exchange the position, and I know that the x will be equal to 1 over 81. Done. So if I put into this back, the complete statement is log to the base 3 of 1 over 81 equals -4. Okay, that is for number one. How about number two? Number two, we don't know the exponent. We don't know the logarithm means. So let us translate into the exponential equation. So the base is 2, right? And the exponent is x equals 1 over 8. Okay, and as we have learned before from exponential, that whenever we have this exponential equation, try your best to make the base equals to, from the left and the right member. So let me just make, I will transform the right member into this, right? 1 over 8 is 2 to the -3 power. So therefore, x must be equal to -3. So in the end, if I put back this answer into this one, of course, I have the complete statement that log to the base 2 of 1/8 equals -3. Because 2 the power of -3 will be equal to this. Okay, so yeah, you can find the x by transforming that logarithm into exponential. That's the key point. Okay, so let's finish the examples. How about this one and this one? You don't know the base. Okay, x as the base. So let's just transform this into exponential equation. So the statement becomes x the base raised to the 2/3 power, right, equals 4. Now, sometimes you forget how to solve this one, right? Let me just give you a reminder. Whenever I have x to the half power equals to 3, to find the x, actually we square both sides, right? Why? So the objective is I want to make the exponent of x gone or 1. I'm sorry, not gone. So I square both sides, square both sides. The objective is to make the exponent of the left or x will be 1. So x equals 9. That's the objective. Okay, let me just I'll give you another example. If I have x cubed equals 27, actually you can solve it this way. I know that x cubed equals 3 cubed, right? Therefore, I will do this. So I raise both members, left and right, to the 1/3 power. Okay, in the end, I have the statement that x equals 3. Okay, so the objective is to make the exponent of dx, the one that we are trying to find, it equals 1. So how about this one? Let's go back to the previous example. Since I know that there is an exponent here for the x, okay, so I need to make it 1 to solve this situation, to solve this equation, to find the x. So how to make the exponent becomes 1? So I need to raise both member to the 3/2 power. Okay, so this is then, and in the end, I will have x, since it is canceling each other, equals, well, 4, remember 4 is 2 square, so it is 3/2 cross cross, so it is 2 cube, so it is 8. Okay, that's how you deal with it. Okay, so now see, uh, first I want to remind you that when you write the base, yeah, you have to be clear. It is quite, yeah, it's not on the same level. So now, if I want to solve this, I always transform this into exponential equation. So it becomes x, the base, to the 3/2 power equals 1/. Okay, but I don't like this one. I think I need to transform this into equals. I know that 216 is 6 cubed. Okay, therefore x 3/2 equals 6 power negative 3. Now how to solve this one? I have to make this into 1, right? So let's just use other color. So I do the same thing to the left and right member. I will raise it to the 2/3 power, both. Okay, the objective is to make this exponent becomes 1. So in the end, I will have x equals 6 to the power of negative 2. So x equals 1/36. So that is how you solve for x in these logarithm problems. I hope you can do your practice, and yeah, good luck with your practice, and please ask if you have questions. You can direct the questions to my email or my personal WhatsApp or line. Thank you for watching.